The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the December webinar series. Today's presenter is Amy Phillips, and she will be presenting Improve the Process by Taking Control from her presentation at the EuroSTAR Conference 2013 in Gothenburg. If you have any questions for Amy, please type them into the questions field on your control panel, and I will address these questions to Amy directly at the end of the webinar. You can type your questions at any point during the course of the webinar. The webinar slides, as well as a recording of the webinar, will be available on the EuroSTAR website shortly after the webinar ends. You can join the conversation on Twitter using the hashtag ESConfs. You can connect with EuroSTAR conferences by using the Twitter handle @ESConfs, and you can also connect with Amy by using the Twitter handle @ItJustBroke. And I will now hand you over to today's presenter, Amy. Hello, Amy.
Hello. Thank you all for joining me. Just get the slides up. So hopefully we should have plenty of time at the end for questions, so please do type away as I'm going through the slides. So I am the head of test at Songkick. We provide live music alerts globally, and we started out on the web, so on songkick.com. And then over the last few years, we've moved to be multi-platform. So we have an iOS app and an Android app, and we also have an app that lives within the Spotify desktop client. So we have quite a lot of things going on, and we are a startup, so we're quite a small team, but we're used to moving quite fast. So I mention that because we have sort of lots of different people working on different parts of the system, but it's all quite closely tied together underneath. And obviously small teams mean that you don't have lots of people to split into nice independent teams. We're all working on multiple things at any one time. But like all development teams, really our goal is to deliver great products to the users, and we aim to have our releases be as stress-free and predictable as possible. So just talking a little bit more about releases, obviously every time you make a release, you hope that you don't break anything critical. I think it's fairly expected that there will be some problems in production, but hopefully nothing unexpected. And you want to try and avoid having any unnecessary delays. So usually these come in because somebody isn't aware that they have a role to play in making the release, or something unexpected comes up. Often you can't get hold of the right person at the right time. And all of these things mean that the business people really need to understand your release process. So if you're saying the release will go out on Tuesday, and then due to all these sort of unexpected delays going on, it ends up being Thursday, then your business people need to really understand what's happening and why. And throughout all of this, of course, releases are just really stressful. And so it's quite useful to try and have reliable build and release processes. There's nothing that quite adds to the stress as knowing you're putting in maybe a high-risk change into production, and everybody's a bit uncertain about making the release, only to find that perhaps your production deploy scripts turn out to be different from your test environment deploy scripts, or they fail in some unexpected way. So that really does add quite a lot of stress. So it's best to make those as reliable and predictable as you possibly can. So back in 2011 at Songkick, we hit a bit of a problem because we'd been going along happily. We had a process in place for managing our releases. Generally, they went reasonably smoothly. We didn't have too many unexpected problems with making the releases, but we did have a lot of unexpected delays. And in particular, we had quite a complex process which really relied on people outside the development team understanding what our process was and knowing when they needed to be involved. And so it looks something like this. This was actually managed as a physical Kanban board on a whiteboard. So we had these blue squares represent index cards for the features, and then we would move them along the board as things happened. which in our world was quite slow. You know, we sort of represented that if you had time to be moving physical cards around, we probably weren't going as fast as we could. But basically, when a developer started coding a new feature or a bug fix or something like that, they put the blue feature card in the coding column on the board. And then at the point they felt they'd completed the code and it was ready to go to production, they would move it into the ready to commit column. And this worked as a queue, so your card always went into the bottom. We didn't do any sort of analysis of what should be released first. It was just when you join the queue, you join the end. And then one at a time, we would pull these cards in, and the code would get integrated into Git, and that would trigger our unit and integration tests being run, and Jenkins managed all of that. And hopefully, we've got a green build. And then if we did, we deployed the build onto our test environment, and then that was when I really came in, and I would do acceptance testing and regression testing and lots of things like that. But as part of our acceptance testing, we also had a sign-off process for the design, so we'd need a designer to sign off. We would need to sign off on the copy, so that was usually the product manager. We would need to sign off on the sort of interruption, so this new feature actually does work in the way we hoped it would, and we feel we can sort of interact with it nicely. So that was our UX designer. And then obviously I was there signing off on the sort of regression side of things, you know, does it do what we hope it would do? So there were lots of people involved in this, there were lots of delays. And we also have a bit of a problem that we tend to try and aim for perfection, which sounds great, you know, let's do loads of testing and let's be really careful and fix all the issues we find. But in reality, you will still find things in production, it's just you're going that much slower. So we would find all these bugs, and we would want to tweak the copy, and we would want to tweak the design. And then what we would do is, rather than push to production and fix them later, we would actually fix them now and run another build, deploy another build to test environment, and do some more testing. So it was a very slow process, and there were lots of people involved in it. And only at the point when that code made it onto production, we were happy, the deployment worked, the feature was there, live, only then would the next card come in. So from our point of view, it was fairly sane, you know, like each card went through, we did all the same checks and testing, we had sign-off processes in place. The problem was really the queue. So developers would say, okay, great, I've finished working on this feature, and then it would sit in a queue for perhaps 4 or 5 days. You know, like we had the tests and checks were taking around about 3 or 4 hours to complete. But because we were aiming for perfection, we'd usually run through at least 2 cycles of that. So we could generally do 1 release a day, and things were obviously queuing up in the meantime. So we needed to really understand how we'd ended up in this place. And when you look back, when you sort of stand back and really look at your process, I think every process really rises through sort of evolution. You define a process at the beginning, but the process you're actually following is probably slightly different. And in our case, we found that each time something had gone wrong, so each time a release had had an unexpected delay, or you know, it had an unexpected problem in production, or maybe deploy had failed, each time we would increase our pre-release checks. So we might add some additional deployment testing, or we might add an additional sort of sign-off before we did the deploy. And then we would apply that blanket vault to every release subsequently. So we didn't do any risk analysis. We just said, okay, that feature, the copy was wrong. We accidentally released it with what was placeholder copy rather than real copy. So now we cannot release anything without having copy approved beforehand. And over time, adding those sorts of checks without doing any sort of analysis as to whether they are really helpful and whether they're really needed will just slow down the process. So we had eventually reached the stage where we had such a safe process that we could barely release anything at all. So we were quite, you know, honest with ourselves. We knew we needed to change. The developers were very frustrated because they had code just sitting around. They wanted to move on to the next thing. Our business people were very frustrated because they had these new features and they were being told that it was done, the code was finished, but it would sit in a queue for half a week because we couldn't get a release out. And I was very frustrated because everybody was asking me when testing would be finished. So we knew we had to make a change. And we realized we had two options, really. We could either formalize our process a little bit more and move to scheduled releases, and perhaps have one every week or every fortnight. And that would mean that everybody could, all these features that were sitting in a queue would be bundled together, and we would have a known release day. And that would mean that business people could expect a release, so maybe every Tuesday they get a release, and they would know they need to be around for sign-off on their Monday. It would mean we wouldn't have to run through multiple cycles of regression testing. We could probably do that a little closer to the release date and just do it once or twice. But the downside was that generally at some point you need to have a code freeze, because if you're going to manage to release every Tuesday, at some point, maybe every Friday, you have to code freeze. And you have to manage that process and be very strict about yourself. So maybe you need a role, and somebody actually needs to take responsibility for managing that and controlling what goes in and out, which we didn't have anybody doing something like that. And we tend to like to live by the principle of getting code out to production as soon as possible. So we don't really like having features which are complete and ready, but they can't be released to production. And they can't be released because our process says they can't be, not for any other reason. And in particular, once you start thinking about bug fixes, that gets more difficult. Like, you have to learn to manage, well, how do you do a patch release? Do you do a patch release? And how do you coordinate that? So we didn't really feel that it was really addressing our problems in the right way. So the alternative really was to move to continuous integration, and was to actually stop trying to manage our releases in such a manual method, but to actually step back and look at how we test builds and what checks we have in place, and actually allow that to do the managing for us. And just trust that things would work better, rather than just trying to always control, like, one change can go in at a time. Have the right checks in place so that if 10 changes go in, that's fine. We have the same checks running, and if one of those 10 things fails, we know about it and we can deal with it. So we decided to go down that path, which at the time, of not being able to really release anything, felt quite ambitious. But I think often having quite an ambitious vision is quite a nice way to go, because it doesn't have to be something you can complete next month. In our case, it took about 6 months to fully realize our vision. But it meant that everybody had a chance to think about it. Where were we aiming? This would be a sort of significant cultural shift for the whole company. And then we could start to take small steps to get there. So once we had the buy-in from all the development team and our business team, and everybody really needs to commit to what you're trying to achieve, then we could start trying to make things happen. So the first step was to really define a single test strategy. And I think this happens in so many teams, where you have developers coding away, and quite often they're also writing unit tests and integration tests. And in many cases, they're actually also doing some manual checking of the feature, the code. But somehow this giant wall has sort of grown up and splits the developers off from the testers. And so at some point, the feature gets handed over, and the testers start doing feature testing, and maybe they're doing some regression testing, and they most likely have some automated checks that they use. And these things exist entirely sort of independently, and there is no sharing of knowledge at all between these two sort of teams, even though they all belong to the same development team. And so the first step really is, if you break down the wall, then you can start to have one test strategy, and you can start to consider what gets tested and when and how. And if you bring all these tests and activities together, you find there's actually a lot of overlap. So I think it's quite common that testers carry out tests and checks which a developer has already performed. And they probably find, well, either nothing because the developer fixed it, or they find something which nobody is really interested in fixing. And as well as that, you have these gaps that probably exist. So because you have so much overlap, you're missing the opportunity to actually explore in a greater depth. So if you consider these all as one test strategy, then you can start to think about the team effort. So you have people, and they have the effort available to them to carry out testing. And then you can start to decide, okay, where do we want to make the split here? What is going to be testing, and testing in a kind of exploratory way, you know, finding out information and using that to learn about the system and find unexpected issues. And what effort do we want to spend on checking? So checking things that we know what we're expecting the result to be. We probably want to have checking split down further, like at what level is this going to be machine checking, so repeatable checks that we can run time and time again, versus human checking, which maybe you want to just check that the tests and things you've put in place are running as you expect them to. And if you consider the whole load of this testing activity to just be something that the team performs, then you can actually start to think about it in terms of risk and actually work out where you want to focus your efforts on the risk. So I think it's worth mentioning that, you know, developers quite often do fairly decent testing. Certainly they understand quite a lot about technical risks, but I think their general weakness is in understanding risks from the user's perspective. So perhaps thinking about the system less about how the code interacts and more about how the users are actually hoping to use the system, the actions they're hoping to achieve. So I think bringing everybody together and thinking about it from a team point of view, you know, testers can get much more technical insight, developers can get much more user insight, and together you can actually agree on where do you feel the risks are and how can you best mitigate those. So just a quick recap, we had this process where we could only integrate one thing at a time because we were concerned about the unexpected impact that maybe multiple things coming together, they might not integrate correctly, or one of them may hold up the other. And we relied heavily on the business people understanding our process so they could be available at the right time to sign the environment. And together these things meant that we had a very slow process, we had lots of unpredictable results. And quite a lot of that came down to the fact that we were finding so many issues once we actually got to the test environments. So we had this single test strategy and we had everybody thinking about risks, and we decided that we needed the levels of testing that we had in place. So we had like unit tests and integration tests running as part of our build process. And we knew we needed to do acceptance testing on the individual stories. And we knew we needed to do regression testing on the releases. So we decided to take a look at that and consider speeding things up by adding in a new testing step, I guess, phase. So now, at the point where the developers felt their code was complete, rather than moving straight to the ready-to-commit queue or committing their code, they would actually open it up for testing. And this was mostly acceptance testing. So this meant that we no longer had delays in waiting for the right people to be around because, well, we had delays for this one particular story, but we didn't have delays across the whole team waiting for this person. If you needed a design person to sign off on a design for a feature, then you would wait for your design person. Meanwhile, other releases were going on, other bug fixes could still continue out. We weren't blocking up our release pipeline. And it meant that we did all this testing on a developer's local environment. So we hadn't committed the code at this stage, which meant that fixing bugs was pretty quick and easy. In most cases, people paired up. So you'd actually find a designer and a developer pairing together to walk through what the design was like. More people getting involved in exploratory testing. And we were getting much more bug fixes going on. So that was really great. Now, in theory, this means that when the code was integrated, provided all our automated checks and build process worked, we could probably move through the test environment fairly quickly. We could just run some regression testing, maybe a quick check on the acceptance, but we wouldn't be having to do this in-depth checking, and then we could go to production. So it all sounds great. But one of the downsides, of course, is we haven't integrated the code at this point. So we have increased the risk because we are now testing on code that hasn't integrated. So you may find later on that you get more unexpected integration errors. We're testing on a developer's environment, so you're less likely to have production data. You certainly don't have a production config. You don't have load. There are lots of things like that which you just get for free on test environments and certainly on production environments. So we were increasing the risk a little bit. And so we felt that this was certainly beneficial. It helped us a lot with our acceptance testing, but it probably wasn't enough on its own. So we added another testing phase. So we now actually are doing a lot more testing than we ever were. So we've increased the amount of testing we do. And now we have this testing stage in production. And so the process is starting to look like the developer spends some time coding. They think they've finished their new feature. And lots of people swarm and do testing on that new feature, so people with different backgrounds and roles. If we are happy, then the code can be committed. We run some automated checks and build. And then rather than doing testing on the test environment, we now only need to do some checking. We're doing some regression checks. We're doing perhaps a few final acceptance checks, but nothing too in-depth. Then we can deploy the code to production. And then at this point, we can go back and we can spend as long as we like doing testing. We have production data. We have production load. We will get lots of things like that for free. You'll see lots of issues that you never thought were possible with pagination, timing, and all sorts of things like that, which you just get for free by testing on production. Now, obviously, testing on production is not ideal. You don't want your users seeing all these half-built features and testing things for you. You know, we're not Microsoft trying to get our users to do our testing for us. And so we actually started using a lot of feature flippers. And so releasing Songkick doesn't have to mean we launch the code. We've separated out our releases from our launches. And we've done that by using what we call feature flippers, which are quite simply if-else statements within our code. And these are all managed by a control panel, which is just a web page, which anybody in the company can actually access and control. So we can decide at any time this feature is only ready for testing. It's on production, but it's not ready for users to start using it. So we can set it for available within the office only, or for admin users only. And then we can spend as long as we need to actually testing this in depth. We can carry out security testing and performance testing and lots of things like that. And then at the point which we feel, okay, it's ready, we're happy, we can launch it just by changing our switch and actually making it available to everybody, or to a percentage of our user base. You know, sometimes we launch things and you can launch to 5%, 1%, and let people come in and see how it performs and see how they react to it. And one nice sort of side effect that you get with this sort of approach is if something goes wrong, you can turn it off. So if we do discover that it doesn't behave as we expect, or there's a critical bug that we need to get fixed, we can just turn the feature off, and we don't need to even release to do that. Then we can make a bug fix and we can have another go. So you get sort of a nice bit of added control there from using this approach. And so we've got this test approach. We've started to make improvements to our process. We've started to tweak where testing fits in and how it fits in. But we still have a pretty slow process. Our tests were taking an hour to run. And when we stepped back and looked into what was taking so long in these automated like regression checks, unit tests and things, we found that actually majority of our checks were taking place at integration level. And actually we were finding they were mostly sort of end-to-end type things. So they would actually load up most of the parts of the technology stack. And in lots of cases they would actually hit the database too. And so we found that we did some analysis and we got involved. Developers were very motivated to get involved at this stage. We found we were able to move lots of our checks down and increase the unit test coverage we had, which means hopefully you can sort of keep a reasonable level of coverage whilst speeding up the build. And we reviewed what we were testing at integration level, and again, some of those we didn't need, some of those could move up or down to different levels. And then, because we'd increased risk again by having more unit tests, so testing smaller chunks of the code versus the integration, which was testing sort of parts of the code working together, we added in some end-to-end acceptance testing. And this was quite an interesting part because we actually went to the business and asked them, what are the critical areas of the system? What should we never release? You know, if we know there's a problem in this area, what would you never want us to release? And with them, we defined some journeys. So our users tend not to come to the website and press a button and leave. So we actually define them as journeys. We have users coming in and signing up and tracking artists and tracking locations. And by that, we give ourselves enough confidence that the core journeys are working and they will, you know, the user can actually load the browser and see these things happening, that we can accept slightly increased risk of having more unit tests versus integration tests. And the benefits of these really is just simply that you have faster automated builds. So when you push our code into Git, now, rather than taking an hour to run through all the checks and produce a build, it tends to take about 5 minutes. So it's much faster. And this is all coming back to fast feedback. So you want to have your checks going as fast as possible because it really does drive the way people behave. If people know it will take, if they push code and they know it will take an hour to run through all the checks and produce a build, then they will almost always push right before they go for lunch. Which is fine. If it goes green, they come back from lunch and they have a green build, no problem. But if it goes red, everybody else has to wait for them to come back from lunch before they can make any fixes. Then you have to run it again, and so it takes 2 hours basically to fix a red build versus 1 hour if they were watching it. So if you keep it below 10 minutes, people tend not to disappear. They tend not to get caught up in different tasks and not notice when the builds go red. And one way to reduce your builds going red is really to have checks that can run locally. So our developers all work on these local developer environments. We make it really easy and really fast to run all of the regression checks from their local environment. And that just means that when you do get broken builds coming from your build server, they're much more unusual. You know, it's not just somebody's violated a unit test. It's actually something like the code has not integrated correctly. But you get far fewer of them if all the checks are running locally. And there seems to be a sort of traditional view that you should run unit tests and then integration tests and then acceptance tests and run them sort of building up, which, sure, that might work well for you, but you should really consider whether it is the most sensible order. If you have an integration test which fails quite frequently, then you don't really want to run it 50 minutes into a build. You want to get it running as fast as possible. Have that one run first. If it fails 50% of the time, run that first, and then you don't have to wait and run the majority of your checks just to find out this one failed. So play around, you know, run them in whatever works so you get the fastest possible feedback. And then you've got this great test strategy, and you've done the work you need to make the checks fast, and you have them running at the correct level, and hopefully you're testing all the right things. But then you need to learn to trust these test results. And I think there will always be a point where somebody, and usually it's a developer, will decide that a red build doesn't really mean that the build failed. It was something different. So maybe it was bad data, or maybe you had the wrong config, or whatever the reason. There will be something that makes them convince themselves, and probably others, that this build can still be released to production despite the fact that your checks have failed. And on the flip side, you tend to have people who don't trust the green builds. And these would tend to be the testers. So you tend to find that you get this build and it's green, but the tester's still nervous. Like, I must check a load more things. It can't possibly work. How is that true? And so in both of these cases, you really need to get to the stage where you trust your results. You need to have whatever tests you need running and running reliably so that every time the build says it's green, it truly means that that code is fit to go. If it's red, something broke. You can't have anything that means that neither of those is true or either of those is true. So do whatever you need to do to make that reliable. And then we found we've been focusing, our end goal was on continuous deployment, and we'd been focusing on the steps to get through continuous integration, because that's obviously the first step of continuous deployment. And then we found that once we were performing all these write tests, and we had them running at the right time, and then running at the right level, we had our feedback running nice and fast. And we'd automated our build and deploy process, so if a build was green, it was automatically deployed to our test environment, and that would automatically trigger off any of the regression checks and Selenium tests and anything like that that we needed to run at that point. And then if they were green and everything looked well, it was automatically deployed to production. We found we'd accidentally ended up with continuous deployment. So actually the final stage of this process was far easier than we imagined. The biggest challenge was having the vision and getting started and taking the steps to get to here. So our process ended up looking more like this. So we now have developers coding away, and there are checks and testing going on at the same time. So, everybody is involved in this stage. And then whenever we're all happy and we think it really is complete, the code is committed and build kicks off. So we're running all of our machine checks and integration and everything like that. And then if that goes green, it's deployed to our test environment where we can run more machine checks. In this case, it's Selenium. So we fire up the browser and we test some end-to-end business-defined journeys. And then if that goes well, we deploy to production, and then we continue testing. So we're doing quite a lot of our testing in production at the moment. And this was the impact we had. So it took us about 6 months to get there. And since then, we've been averaging around about 100 releases a month. And that's not really through doing more work. We don't have a bigger team. It's simply by opening up the release pipeline, allowing developers to integrate code when they're ready to integrate, and actually having things moving much faster. So the impact of having a much faster build and test time is that developers are much more motivated to make trivial bug fixes. We found an awful lot of people suddenly had bugbears that they wanted to fix as soon as they knew the releases were stress-free and pain-free. They just got it going. So we tend to have higher releases because of that. But although our goal really was to open up our release pipeline and get things flowing again, it ended up being much more than that. We ended up having this thing where everybody cares about testing. Because we have a single test strategy, and because the developers understand that they can't do these sorts of releases if we don't have the right checks in place, and if we're not doing the testing at the right places. So everybody now is involved, and everybody cares, and is busy maintaining our tests, keeping things fast, making sure that when we build new features, we also consider what checks we need to add to our builds. And the business were particularly happy to discover that bug fixes often just take minutes. So it's quite nice if you do have a problem in production, especially if maybe a user contacts you and says this is wrong, to be able to put a bug fix out 15 minutes later to get the whole problem fixed. So that's quite a nice addition that we weren't really expecting, but came along anyway. So this worked, I believe, because we agreed on an end goal. So we knew where we were all wanted to get to. Everybody had the option to debate that and raise their concerns, and we addressed those. And then everybody was able to just work freely to take the steps we needed to get to that end goal. And you need to stay risk focused. So our original process was very slow because we weren't considering risk on an individual feature level. But now, especially because we have this ability to flip features on and off, we tend to talk about risks much more. So we tend to consider, is this a feature that needs to be turned off in production so we can carry out more extensive testing? Or is it low risk? And how does that affect users and the business and all those things? And developers are much more aware of the risk when they're actually going through their checks and testing and things like that. And obviously there's communication throughout the whole team. So one of our initial problems, as I said, was that business needed to understand our release process in order for it to work. So they also need to understand why you're going through a process like this, what you hope to change, and they need to be involved. So we talked to them about what their concerns were with releases, and we hopefully have addressed their risk levels with our end-to-end tests. And then there will always be problems. These things, you know, it's a learning curve. There will always be times where you release something and it doesn't go quite as you hope. But you need to not lock down the whole process. One problem doesn't mean the whole thing has failed. You do need to know how you're going to prevent that particular problem happening again. So you need to drive positive change. So maybe that's human error, in which case perhaps a more sort of automated process control you could put in. Maybe code reviews, or maybe you need more testing or additional checks, and things like that to actually enable you to continue with this sort of process, but while still addressing these risks. And I think testers already have many of these skills. So I think it's fairly unusual for testers to actually drive a process like this. We're much more commonly seen sort of thinking we should lock it down and add more testing. But actually, we found at Songkick that we don't do less testing, we do more, and we have much greater input into the whole process, with much more input coming in from developers on how we can address these risks. So it was really a positive thing. But testers are very used to thinking about risk and knowing what sort of testing and checks you need to put in place to actually try and mitigate these risks. And testers are used to talking to business people and developers and having this sort of shared communication throughout the whole team. So it really does make quite a lot of sense for testers to at least be involved in this process, if not driving it. So I think it's worth just finishing up with a reminder that when you make a release, you're releasing something to the business. And you need to be aware that you have the potential to break everything. You need to manage that risk. But you can do this if we just manage people and activities that make up that development process. And so though I focus here on testing, just remember that testing is there to provide the information to your process. So you're using the information you're finding to make better informed decisions. Thank you.
Thank you very much for that presentation, Amy. We'll now open the floor to your questions. So if you have any questions and you haven't already typed them, you can do so now. So I'm just going to open up my screen here. So while you're typing your questions for Amy, let me bring your attention to our EuroSTAR webinar archive. Here you can view a recording of this webinar, as well as viewing over 85 other webinars on a wide variety of testing topics. Finally, the call for submissions to speak at the 2014 EuroSTAR conference in Dublin is now open. The theme for next year's conference is Diversity, Innovation, Leadership, as chosen by Programme Chair 2014, Paul Gerard. The deadline for submission is February 14th, and for more information on how to submit, please visit the EuroSTAR website. We will now look at some of your questions. So the first question I have for you, Amy, is, did you have an increase in bugs in production?
Well, yes. I think if you're counting just bugs in production, then yes, we did, because we carry out more of our testing in production. But I think the important thing for us was, did we have more bug reports coming in from users? Or certainly were we experiencing more, we monitored Twitter quite closely, so we were interested to see if people were finding a reduction in quality, and we didn't experience that. So although, yes, technically we have more bugs being reported in production, I don't think quality is lower in production.
The next question is, what is the difference between checks and tests?
Okay, so checks are generally things where you know what the outcome should be. So at Songkick, we tend to carry out most of our checks are like automated checks that we have. So, if I press this button, I know what the expected outcome should be, and I can check for that. We do some sort of manual checking as well, where we have sort of checklists, and again, it's if I type in this string in this field, I know what the outcome should be. Whereas testing is much more around exploring, and we like to do quite a lot of exploratory testing. We've started doing it fairly recently, but it's quite interesting to have this sort of open-ended goal, and actually to be focusing on things that you perhaps can't predict what the outcome will be, or you weren't expecting to need to focus on particular areas of the site. So testing is much less defined. We will tend to go in with a goal, but not worry too much about knowing what the system should do at any one point, and just find information and see where that leads us.
The next question, it's a little bit long, so if you need me to repeat, that's no problem, just let me know. And the question is, when you have a configurable functionality, i.e. available or unavailable, how did that impact your non-functional testing considerations?
Okay, well, we tend to focus most of our like our release pipeline, we tend to focus mostly on regression. And the reason for that is because we can turn things on and off. So generally our non-functional testing would be something which we would carry out, maybe not necessarily in production, but certainly after releasing code to production. So sometimes we run a release and we put the code in production but have it switched off. And then we can carry out performance testing on a test environment, for example, for as long as we need to. But and that would just be solely focused on the sort of new feature. So we tend to split it that way. And then once we're happy and once the feature's live, if we need to continue doing sort of monitoring and making sure we don't regress on the performance or security or any of the other things, then we would add in checks, because at that point it's fairly expected. We know that it's acceptable, that it makes, that it allows, I don't know, like 10,000 users at this point. So we can actually put load tests in place that would run automatically to monitor that for us.
The next question here is, how did you fit in security and performance testing?
Okay, yeah, so it follows on well. We manage those on a feature-by-feature basis, generally. So if we have a new feature coming in that we know it's high risk, and we know we need to consider security or performance particularly for it, then it would almost certainly be something which we have switched off at the point we release the code to production, and then we would take the time to do that. So we may bring people in to help us with security or performance or things like that, or it might be something we do in-house, but we do it on a separate environment so we can control that. And then it's got to the stage now where we have quite a few, we have some sort of load tests and we have performance monitoring built into our Jenkins build. So we run these, and if it dips below acceptable levels, we fail the build. And we also have things like security checks. We can manage those at unit test level. And if there's anything else, we don't have any at the moment, but if there were to have some, then I would see that we could perhaps have another like Selenium style end-to-end test that would cover that for us. So we try and, from a new feature, we would test it like separately from our releases, but once we have a feature live and it sort of goes into regression, we would try and get as much of that automated as we could.
The next question is E2E part of checks or part of testing? And the same question for unit level testing.
Okay. I'd say both of them are parts of checks, because you have to define what you're expecting to happen. So in that case, we are, each time we do a release, we are literally checking that the sign up, when you fill these fields in this order and you press this button, it works. Whereas testing would be much more around exploring, like trying, what if you fill all the fields in a different order? What if they're all empty or full of junk and things like that? So we tend to focus our end-to-end testing much more on happy sort of path. We're trying to make sure that users can perform the actions they want to perform. And then we use exploratory testing much more to explore, okay, can I break it if I do all of these crazy things?
The next question is, who is responsible for writing the end-to-end automated tests, QA or devs, or what is a
Actually,
combined
everybody.
effort?
Sorry, I missed the end there.
Sorry, the last part of the question there is, or is it a combined effort? So
Right,
I think
yeah.
you kind of answered that there.
Yeah, yeah, it's absolutely a combined effort. So, I mean, it depends what update we're making. So when we created them initially, it was sit down with the business people and agree on what the journey should be. And I believe Dev wrote them at that point. Since then, though, if we know there is, it comes down to what sort of requires the maintenance. So if we need to maintain them because I think we need to add in some additional checks, or the business would like to add in some additional checks, then I would probably do that because, I'm a tester, I'm the one who would like to see that happen, so I would make the change. But if we're implementing a new feature and that feature will break these checks, then it will be part of the feature work, and the developer would do it at the same time they actually build the feature. They would update all of these checks so that they continue to work. So, I mean, it's really a bit of a combined effort, and I think that's one of the nice things about continuous deployment, because we have it fully automated. If these checks fail, the code doesn't go to production. And so everybody cares that they continue to pass. So the developers are motivated to keep them passing and keep them maintained so that the code does actually flow through and get deployed to production.
The next question says, so you have an average of 5 releases per day. Does all releases make business sense?
I hope so, because I believe that the only reason you would be doing a release is because the business is going to gain something from it. So perhaps they gain a cleaner code base, or a more performant code base, or a new feature or bug fix. So yes, I would hope that every release does make business sense, to be honest.
The next question is, how do you ensure that the bug fixes verified locally at the code stage reach the final build?
That's down to the developers. That's the developer's responsibility. I'm sure we have had cases where we've missed a few things, but it's not very common. I think we don't have any sort of process checks in place for that. We haven't had any need to make the process more formal at this stage. But I guess, when the build goes onto the test environment, there is a period where we are running these end-to-end tests. You can do some sort of checking over there if need be, but I think it just comes down to responsibility, developer responsibility, and our process really trusts that the developers will at least try their best to make this work.
The next question is, do you have a dedicated QA team, or are all testers integrated into development teams, and how many testers in total?
I say we have an amazingly dedicated and integrated test team of 1. So I'm the only tester. And we currently have 3 developer teams. So yeah, I split my time across the 3 teams, which has worked quite well with this process because, as I say, everybody is motivated to care about testing and quality. And so I'm there much more to guide them in their exploratory. Like, we find the checks very easy to define. We can do that as a group. What are the things we need to make sure work? And then it's more the exploratory testing that they need guidance on to help, to train people in how to test and help them understand where the risk areas are, and maybe try and help them predict what sort of bugs they're going to find.
Next question, how did you get buy-in from management?
Well, I think that's always a challenge. In our case, it wasn't a huge challenge because we just presented our case. We could see the trend in the releases we were putting out, and we were slowing down. So we sort of hit a stage where we were getting releases out, but we were only getting out perhaps four or so a week. And we looked at what was delaying them, and it wasn't that we were getting 4 out a week because we only had 4 to get our release each week. It was we could work out based on our queue how many potential releases we could make each week. Given our process was better, we would be making 10 or 15 or some greater number. And then we actually presented that to the business. And I think it's partially that, like, you know, actually having the buy-in from the people who want the releases. So it's not necessarily just the management, it's much more the user support people who want to get bug fixes out quickly. It's product managers who want to get features out quickly. Having all of these people understand that if you can improve your process, and if they buy in and support you in improving that process, then you can actually move much faster and actually make these changes. And, you know, involving them. So obviously they were quite concerned about risk. Once they sort of agreed that we needed to do something, they were mostly concerned about, you're just going to push code to production, what if you break everything? And so then it's much more about helping them understand risk and helping them understand what we have already done to consider the risk and the sort of what checks have we put in place to help mitigate that.
The next question is, how do you track exploratory testing?
Well, we don't really track it as such. I think everybody is quite focused on quality and wanting us to have the best product available for our users. And so people tend to carry out exploratory testing fairly naturally anyway. They are using the website, they're using our mobile apps, and they report problems as they find them. So we tend to have slightly more forced exploratory test sessions, so there may be a day or periods within the day where people are encouraged to carry out exploratory testing. And that's when I will work with them to help them consider areas they could carry out or you know, help them get set up or anything like that. But we don't track it as such. I think we know when we haven't been doing enough exploratory testing because we get more sort of unusual reports coming in from users, or we get more things that we start to see in production which we believe we could have found earlier. So I think it's keeping an eye on the quality of production. So I know personally, if I find something reported by a user which looks like a fairly straightforward bug, then I would question why. Like, why did we miss that? How did that get to production? Why haven't we got checks in place that could find that, or why didn't we find that in exploratory testing? And often it's maybe we didn't do enough exploratory testing. So it's just being aware, but we don't have any formal tracking of, you know, how much exploratory testing we're doing or sort of what areas are being tested.
The next question is, who is defining the high-risk releases and what to be tested or not?
Well, that comes down to the majority of our sort of high-risk releases will be new features because they tend to be higher risk because we're making more substantial changes, or we are making like we're sort of building new things, so we perhaps don't understand the technology so well or the impact so greatly. But each time we start one of these new features, we have what we call a kickoff meeting. And so that will be, usually it's myself representing test, there'll be at least one developer, there'll be the product manager, and depending on the release, there might also be somebody representing user support, there may be somebody representing design. We all come together and we discuss what we're going to do, why, how, and all of those things. And that's the point we'll also discuss risk. So the risk is down to, it's a shared understanding, like what, you know, how much do we know about this change? What does the uncertainty tell us? You know, that's obviously increasing our risk. We can talk about whether we are comfortable with the change, or is it new technology that we perhaps need to consider in more depth? And the business people, I mean, ultimately they need to have input as well into what they feel the risks are to the change that we're making. So together we can agree on what risk do we feel this is, how do we mitigate that? What other additional checks we need to be putting in place?
Next question is, do you use the production tests as an automated service monitor once you have released to end users?
Not really, no. We have monitoring in production, but it's not our automated checks. So we tend to monitor activity more. So, I mean, we have talked about monitoring perhaps sign-up rate and then using that to consider whether we potentially introduced the bug because sign-up rates have dropped off or something like that. But we find the traffic to be a bit unpredictable, and so we haven't got a reliable monitor for that at the moment. So we do have monitoring in place, but it's different. It's different from our automated checks.
The next question is also quite a long question, so if you need me to repeat it, I will. And the question is, consider a release with 5 development teams involved. Consider that the teams work independently from each other and each has a different release delivery date. How do you plan the E2E tests? Is there a role managing the release throughout all the teams involved?
Well, I think it depends. If they're all using the same code base, then absolutely, you need to have, these end-to-end tests should be considered as they're your final safety net. They are the thing which hopefully means users can continue to carry out the critical actions within the system. So if each of these 5 teams is modifying the same code base, then absolutely they need to have the same checks running before they make a release. And we probably want to have somebody from each of the 5 teams representing, talking through what journeys are critical for them, like what stuff do they need to make sure you never break. I think when you've got these multiple teams, the risk of breaking things is much higher because you've got 4 teams who know nothing about what the 5th team's working on, but potentially using the same code base. So you need to perhaps have more coverage in those cases.
Okay, I think we're just about out of time there, so we're just going to leave it at that. And I just want to thank today's presenter, Amy, for today's presentation. And I'd also like to thank all the attendees for attending and all your questions. The webinar is now over. Thank you, and goodbye.
Thanks very much. Bye.